The most diverse substances are transported and distributed in piping systems every single day. They can include solvents and chemicals, vegetable oils in the food sector, coolants in primary industry, or petrochemical products. The fluids flowing through pipes often have completely different properties. Therefore, different principles are required for their measurement. One principle is flow measurement based on the differential transit time method using ultrasound. The basic physics of this principle can be traced back to the English physicist and Nobel Prize winner Lord Rayleigh. His book on the theory of sound, published in 1877, describes the propagation of sound waves in solids and gases. Here is how this measurement method works. Inside the ultrasonic flow meter, pairs of sensors are fitted across from each other in the measuring tube. Each sensor can alternately transmit and receive an ultrasonic signal. Simultaneously, the transit times of these signals are measured. The ultrasonic signals are generated with piezoelectric crystals applying a voltage. Conversely, a piezoelectric crystal creates a voltage when an ultrasonic signal impacts the sensor. By increasing the number of sensor pairs, it's possible to accurately detect and mathematically compensate for flow profile distortions over the entire pipe cross-section. When there is no flow, the signal transit times are the same, upstream and downstream. Once the fluid starts to flow in the measuring tube, the ultrasonic signals are accelerated in the direction of the flow and decelerated against the flow. As a result, the ultrasonic signals now have different transit times, less time in the direction of flow and more time against the flow. Therefore, the differential transit time measured by the sensors is directly proportional to the flow velocity in the pipe. Together with the known tube cross-section, the actual flow volume can then be calculated. The greater the flow velocity, the greater the measured time difference between the two ultrasonic signals. For ultrasonic flow measurement, the sensors do not necessarily have to be fitted into the pipe wall. With a clamp-on system, for example, the sensors are fastened directly onto the outside of the pipe. They can be retrofitted at any time without interrupting the process. With clamp-on sensors, the ultrasonic signal is passed directly through the pipe wall and into the fluid. The signal continues through the fluid, is reflected on the opposite pipe wall, and then measured by the second sensor. In this example, with a two-traverse installation, the clamp-on design is unique because flow rates can be measured in very large pipes, up to 4 meters in diameter. This possibility increases the areas of application, for example in the water and hydroelectric industries. Flexible mounting, process safety, and cost-effectiveness are the distinctive advantages of ultrasonic flow measurement. For all applications, we have the right solution. Endress+Hauser, your single-source supplier for measurement technology.